So just some advice for you on trying to figure out when you're reading mixed problems like you will on the internal and on these revision sheets, when it's an arithmetic sequence and when it's a geometric sequence. So remember, arithmetic sequences, you're plussing or minusing by the same amount each time, and geometric sequences, it's timesing. So adding or subtracting by the same amount each time for your arithmetic or your AS. Words that you might see in the problem could be things like increases by the same amount each week. So something like, she gets $5 more each week, or they put $10 more into their savings account each month. Decreases by the same rate. So kind of same being an important one. The same word, the same amount, the same, right? D is just the same thing every single time. Other vocabulary examples for you in terms of what parts of the formula would be. If you're looking for T, you might have words like find the amount on the 5th day, right? If you're looking for the sum, it's going to be something like find the total after 10 days, or something like how much all together. Anything to imply you're looking for more than one thing combined together. A, you'd have words like the initial amount or the first day, and D is the amount it increases by or decreases by. So if it increases by 5 each day, that's going to be D, 5. And if you're looking for in, it's probably going to be like on what day or on what week will they have a certain amount. Geometric sequences. Again, you're going to be timesing by the same amount each time. It's often going to be a percentage problem, but not always. You might have something that says increases by 3% each month. And remember, if you increase a percentage, it's going to be 1 plus the percentage over 100. So in this case, that's going to become 1 plus 0.03. So R would be R would be equal to 1.03 in that case. Doubles every day. Well, if it's doubling, it's timesing by 2, so R would be 2 there. Is reduced to 1/4 the previous amount each week. So 1/4, well, that's exactly what we do. R becomes 1/4, or R becomes 0.25. For your vocabulary again, your T values, that's the amount for like a single day or a single week or a single hour or whatever the unit is for time. It's the amount on the 5th day. Your sum would be the total after 10 days, and that's the sum formula where you're summing up to the first n values. Now the sum to infinity, remember R has to be less than 1. For that to work, for an infinity formula. And it's going to be something like, how many garbage trucks in total after a billion years have they used? Something that implies that a really long time will have passed, or until it's all done. So anything that is kind of implying the total but not telling you for how long, just saying the total forever, basically implying. A will always be your initial amount, or the first day. And R again is the amount it decreases by or increases by, and this is your timesing value. So remember, when you're increasing to the, when it's percentages and it's increasing, you're going to go 1 plus the decimal, and when it's decreasing, you're going to go 1 minus. And if it's something of, like percent of, not saying increase or decrease, you just go straight to 100, or straight to the decimal, percent divided by 100. And again, similarly, n would be indicating anything on a particular day. So when you get into reading the problems, you've got to pull it apart and read them quite carefully to look to see what's going on between them. If we take a look at this first one, so what page are we on? Page 35. A display of cans in a supermarket has a bottom row of 30 cans. The next row is made up of 28, and the third row is made up of 26. So I can see they're starting to give me the sequence here. So I'm going to have n over t. That's the same for arithmetic or geometric, doesn't matter. The first one is 30, the second one is 28, the third one is 26, and away we go. Looking at this, I'm going to see, well, am I timesing by the same amount, or am I adding by the same amount, or subtracting? And here you can see you're actually decreasing by 2. each time. So we know that this is going to be an arithmetic sequence, and that my d value is going to be -2. So d is equal to -2, a is equal to 30. If there are 10 rows in the cans in total, well, there's a keyword for us. How many cans are there in the top row? So tricky question here. They're not actually asking us to find the total here. They're asking us how many cans are in the top row, so on that particular thing. So here we're implying we want to know when n is equal to 10, what's the t value? So the number of cans on the 10th row is going to be equal to, my formula is a plus n minus 1 times d for arithmetic sequence. So a is going to be 30 plus 10 minus 1 times -2. And the total number of cans that I'll have on the 10th row is going to be 12 cans. How many cans altogether? Okay, so this is going to be your sum. And since I know that there's 10 rows, it's going to be the sum to 10. Again, you'd use your formula, the SN formula for this one. Knowing that n is equal to 10, you've still got A and D. And how many rows could this pattern continue for? Well, this is thinking about it a little bit harder for us. Got this idea of here's our bottom row of cans, our next row, our next row. You can see each time they're getting slightly smaller. So how would you determine when you could have no more rows? And since it's going down by 2 each time, maybe our very last row would have to have 2 cans, because after that you would take the 2 off and there wouldn't be any left. So, how many rows? That's n is equal to I don't know. We're thinking about this situation where we know 1 and 30, 2 and 28. Out here we want to find what's the n when we have 2 cans left. So let's see if we can figure that one out. So Tn is going to be 2. Right? Tn is equal to 2, A is equal to 30, and D is still equal to -2. Plugging into our formula, we have 30 plus something I don't know, minus 1 times -2. And we can put this in the solver. And type in exactly what we see. So 2 is equal to 30 plus bracket something I don't know, minus 1 bracket times -2. Hit enter twice and we get 15. So here n is equal to 15. So we're going to have 15 rows that this pattern can continue for. After that, you wouldn't have any more cans because you take the last 2 off, there's nothing left. So that's just an example for you guys. Work your way carefully through these. Make sure that you're paying attention to, again, the difference between AS and GS and sum and term.